Hello everybody, welcome back to the channel. Josh Martinez here with Paper Free Corporation. And in today's video, I wanted to cover gRPC, which is a more secure encrypted form of communication available in OpenText Capture. OpenText has introduced this protocol to offer a newer form of communication as opposed to the historically used TCP/IP form of communication. Now, it's important that we understand what this is, how to configure it, how to deploy it in our environment, because moving forward, gRPC is the recommended form of communication. Now, what is gRPC? In short, gRPC is a modern communication protocol designed for secure, encrypted data transmission. It's built on the HTTP2 standard, so it's going to bring faster performance, reduced latency, and a more reliable and encrypted communication between the capture server and the client machines. To enable gRPC, there are quite a few steps that we're going to follow, and we're going to cover that in more detail in the next section. But the main idea is that we are going to need an SSL certificate to encrypt the communication between the server and the client machines. And because gRPC reduces network overhead, you'll see an improvement in overall efficiency, especially when you're dealing with high volume environments. To get gRPC working in OpenText Capture, there's a few steps we need to take. Now I'll cover them here at a high level so we get an idea of what that actually entails. First, we start by obtaining a valid SSL certificate from a trusted authority. This can be a self-signed one if you're using a non-production environment or a dev environment or a test environment, but for a production environment, a trusted signed certificate is required. Once we have our certificate, we go ahead and install that on the server and client machines. Now, this installation of the certificate is on the actual capture and client machines. We have not yet gotten to the OpenText Capture side of things. So we install the certificate on both the capture and any client machines using this certificate. Then we configure each machine, whether it's a client machine or server machine, to use that certificate by entering the certificate's thumbprint in the respective gRPC settings, both on the server and on each client machine that's connecting to the OpenText Capture server. To configure the server to use the gRPC communication protocol, we go to the server properties. There's an SSL server thumbprint property there. We edit the value and we enter the thumbprint from our SSL certificate. And that's the configuration of the server settings. To configure the client machines, we'll go to Program Data OpenText Capture directory, and there we have an icsettings.config file. Now, if we open that up, you'll see that we have an SSL client certificate thumbprint property. We enter our thumbprint there, and that's the configuration of gRPC for the client machines. To verify gRPC is configured properly, let's go ahead and open up a module and try to connect using the gRPC protocol. So in this case, we'll open up the image processor module. In the server name, we're going to enter the server name using the gRPC prefix. So we'll go ahead and enter gRPC and the server name. Once logged in, we can click on the connected option in the lower right corner, and we'll see that the connection is using gRPC on port 551. During our analysis and our testing, we tested thousands of batches to ensure we actually had a good test subset. Now, in terms of speed, there was no significant differences as compared to traditional TCP/IP communication. And we actually analyzed real-time traffic, and we analyzed packets being transmitted back and forth between the client and server machine, and there was no delays, and we verified that all the data was being securely encrypted. So with gRPC, you're getting modern security, encrypted communication, secure communication without sacrificing any performance. The final step we wanted to take in our gRPC configuration was to verify that the communication between the client machines and the OpenText Capture server was indeed and in fact encrypted. For this test, we intercepted communication between ScanPlus and the OpenText Capture server. First, we connected to our OpenText Capture server using TCP/IP, which is the historically used protocol which communicates over port 199. We found that the information being sent over TCP/IP was indeed unencrypted and could easily be read. As you can see from the screenshot, we can see information such as the name of our process. So the information being sent is indeed unencrypted. Next, we connected to the OpenText Capture server again using Scan Plus, but now using gRPC on port 551. This time around, the data was fully encrypted. So 3 things worth noting here. 1, we see that the information about the packets has a generic descriptor, just application data. 2nd, the protocol being used is TLS version 1.2, again encrypted. And lastly, the data being sent is encrypted and cannot be read like it was before. So now we can't see process name, we can't see who logged in, username, nothing. The data being sent is encrypted and cannot be read or assembled as it is not binary data. Just to wrap everything up, gRPC is both more secure and more reliable than the traditional TCP/IP protocol used in earlier versions of OpenText Capture. It delivers encrypted communication without introducing any performance issues, even in high-volume environments. So with its modern architecture built on HTTP2, gRPC is a recommended communication method moving forward, especially for organizations prioritizing security, cloud deployment, and long-term reliability.